Play? All right. So today's topic, Lewis structures. Now, Lewis structures do this. They show how electrons are, and here's the big word, shared. Now, let's recall our last couple of days here. This is a big word for us, shared. So we have electrons being shared. So what type of thing does this describe, a Lewis structure?
Covalent.
Things that are covalent. Will it ever talk about something that is ionic? So guys, flat out, I'm going to tell you right now, on tests and quizzes, I can't believe I'm telling you this, I'll do something like this. Draw me the Lewis structure for LiCl. Lithium is what type of thing? A metal. Chlorine is a nonmetal. Therefore, Lewis structures, does it apply to this type of thing? It does not. So all you'd have to write on a test or quiz is, Mr. Gerby, it's impossible because lithium chloride is ionic. Literally, if you wrote that, you get full credit for it. It's impossible because it's ionic. So, you just spent the last few minutes talking about, or reading about, the rules that govern Lewis structures. So a couple things we got to be thinking about. Number one, covalent, covalent, covalent. So this is things that are what types of things? Metals or nonmetals?
Nonmetals.
Always nonmetals. So they're to the right of the staircase. And the other thing is this. You have to remember about valence electrons. Now I'm going to go off the film for a minute, but that's okay. I'm sure it can pick up my voice. So this first group here, right, with lithium and sodium and potassium, how many valence electrons does this whole group have, class? How many valence in this first group?
One.
Two. One. That's right. Now, beryllium, magnesium, calcium, this group, the alkaline metals, how many do they have? Two. You skip all the way across to boron, aluminum, gallium, etc. These have three valence. Then 4, 5, 6, 7, and 8. That is going to be essential for doing Lewis structures. Now, the best way that I know of, guys, to do this is, quite frankly, is to just do examples. So that's why I told you have it butterflied so you can have your rules still in front of you, and then you can have the examples on your right. So that way we can go back and forth as we go. So we'll start with PF3. Rule number 1 says determine the central atom, meaning which atom is in the middle. Central. So, the rule states it's the element that has the lowest electronegativity. Now, in your packets, is there a way for you to look up phosphorus and fluorine and tell what their electronegativities are? Yeah, right? You have an electronegativity chart. So, you get out your packet, you flip it open to the electronegativity values chart, and you find phosphorus, which is 2.1. You find fluorine, which is 4.0. Which one's lower?
Phosphorus.
Phosphorus. So, right away we know phosphorus is the central atom. First thing we do, always. And actually, I'm actually skipping a step. I'm being a touch sloppy. I need to make sure that this thing deserves a Lewis structure at all first. What type of thing is phosphorus and fluorine? They're both nonmetals. Therefore, their electrons share. So does a Lewis structure apply?
Yes.
Yes. Duh, I should have asked that first. Now, central atom. The next thing is you count up valence electrons. So, phosphorus, if we go find it on the periodic table, how many valence electrons does phosphorus have? Well, 1, 2, 3, 4, 5, 6, 7, and 8. And where is phosphorus? It's right here. So it would have 5 valence electrons. So you put a 5. Fluorine. How many valence electrons does it have? It's right here. It's a halogen, and all halogens have 7. How many fluorines do you have? 3. So it's 5 plus 7 plus 7 plus 7 to account for 3 fluorines. The total, therefore, is 26. The next step is this. Take everything and single bond it. Now, what atom belongs in the middle? We've already identified it. Phosphorus does. So you take phosphorus, you put it in the middle. Now, your first attempt at drawing this, a lot of times, is going to be wrong. We'll fix it later. So what I'm going to do, I'm feeling peaceful today. So I'm going to make a peace sign out of my phosphorus and 3 fluorine. Upside down. But what are you going to do? So, boom. If I go like that, I guess, right? So, 3 fluorines and a phosphorus. Here is what a single bond means. A single bond means that you've taken 1 electron from fluorine and 1 from phosphorus, and you bonded, so you share them. So now this fluorine has 2 electrons, that phosphorus has 2 electrons. So every bond consists of 2 electrons. And for now I put big dots to represent them. You don't have to do this the whole way along. Eventually you will just know that a bonded line means 2 electrons. But for now, we'll put those. So how many electrons have we used up just now? 6. You take that number, you subtract it from your 26. Now it leaves you 20. So you single bond everything to the middle atom. Now, we have learned about something called the Octet Rule, meaning that all atoms want to have 8 electrons in their outermost level. The Octet Rule. Well, you just read for a minute on that page about rules for Lewis structures. Were there a few exceptions to that? Yes, they're on that page. I think they're hydrogen, helium, beryllium, bromine, phosphorus, sulfur, and xenon. Okay? Is fluorine an exception? No. So how many does it want then? 8. Well, it's already got 2, right? So it needs how many more? It's already got 2. It wants 8. It needs 6 more. That's all right. You're on film though, so it's awesome.
Oh, great.
So 1, 2, 3, 4, 5, and 6. Now, how many total does this fluorine have? 8. 2, 4, 6, 8. So you subtract 6 because those are the 6 we just added. We have 14 left. Then, this fluorine, right? 6 more. 1, 2, 3, 4, 5, and 6. Notice they always go in pairs. So there's 6 for a total of 8 now left over. This fluorine down here, how many more is it going to want? 6 more. 1, 2, 3, 4, 5, and 6. Leaving 2. Well, when you read your rules, it said you always do the outside atoms first. And after everybody's fulfilled their octet on the outside, the last ones get put on the middle atom. So we have 2 electrons left, don't we? They get put on the phosphorus as a pair. Now we have some counting to do. We know it's the octet rule unless it's an exception. This fluorine right here, does it have 8 valence electrons?
Yes.
2, 4, 6, 8. Is it happy?
Yeah.
This fluorine, is it happy? 2, 4, 6, 8. This fluorine down here, is it happy? 2, 4, 6, 8. Now the last person you got to check, or the last thing you got to check, it's not person, is the fluorine or the phosphorus in the middle.
It has to have 8 though.
So it has to have 8
Mr.
or 10. It'll allow itself to do either one.
Oh, okay.
It's one of our
You're
exceptions.
at 10 minutes.
Okay, well let me finish and then I'll.
Okay.
But are we still taping?
Yeah.
All right, and I will make sure I finish up within like a minute.
Okay.
So 2, 4, 6, 8. So is phosphorus happy?
Yes.
Yes. Now, there is one last thing we have to do to this. And it is called valence shell electron pair repulsion theory. So flip the page in your packet and find this chart right here. This chart has something on it called number of things. And I have it in quotation marks because I hate the word things. I'd rather be more descriptive. Well, we're going to be more descriptive right now. Things refers to the number of atoms that are bonded and the number of lone pairs. Now, let me show you what that means. And it's on the central atom only. So when you look at the central atom here, phosphorus, it has 1 fluorine, right? That's an atom bonded to it. That is 1. This one is 2. This one is 3. And then there's this last thing right here, this pair, that is a lone pair. So there are 4 total things. Now, out of those things, so you go on to 4. You look at how many of them are bonded. It says 3 and 1. So my shape should have been trigonal pyramidal. Where am I on time?
12 minutes.
Okay, good. I gotta hurry though. So trigonal pyramidal. So when you look at the drawing for trigonal pyramidal, it's not all that different from what I have here. It's phosphorus, right, with a lone pair. Fluorine, fluorine, and fluorine. Can't forget the 6 electrons that go on it.
But
Okay?
you have to draw it again?
You gotta draw it again because you have to draw it correctly and with the right shape. Yeah, you gotta draw it again. Absolutely. So you're gonna have a lot of time doing 2 drawings. That is correct. So, trigonal pyramidal. Couple of questions that also might be asked. I might ask you what shape it is. You would tell me it's trigonal pyramidal. I might ask you, what is the angle between the bonds? Meaning this fluorine to that fluorine right there. Well, it's right on the chart. What does it say is your bond angles? Come on, read the chart. For what it's 4, 3, 1. What does it say, y'all? 107.5. And what is the hybridization? sp3. It's done. Good.